Mediterranean region? Did they expect geodynamic seismicity and seismic hazards? What can we do? This talk is done by Dragana Đurić, a PhD in geophysics of the University of Belgrade in the Faculty of Mining and Geology. Are some things about Dragana. She have a bachelor in geology. She have a PhD in geophysics. Right now, is an associate professor at the University of Belgrade in the Faculty of Mining and Geology in the Department of Geophysics. She defines her work as the application of geophysics to solve some geodynamical issues as well as natural hazards phenomena, and it's particularly interested in data and results in the context of natural hazards and disasters risk as management, such as earthquakes, volcanoes, landslides, and floods. She has some industrial projects mainly connected to mineral exploration. Besides this, she's engaged or involved into humanitarian organizations, and her personal commitment is to gender, racially, and nationally neutral science, environmental, and the development of geoscientists regardless of origin, commitment, and starting position. Thank you, Dragana, for give this talk. These are some of our contact lines that you can access, and that's it. The stage is yours, Dragana.
Thank you very much. I'm glad that we solved these technical problems. Thank you again. I'm glad and honored to be here with you. Also, I'm glad that even it's early morning in your home, you are still here and you want to hear something and hopefully learn something new. Okay, I will start a presentation, just a second, just to share my screen. Okay, if in any time something goes wrong, please let me know. Don't write me since I cannot see the chat. Just say something, please. As you have already heard, today's talk is going to be about these recent seismological events within the Eastern Mediterranean region. The major questions are open regarding to these catastrophic events in Turkey-Syria border, such as are they expected? Is this region pronounced to such events? What kind of geodynamic seismicity and seismic hazards are in this region? And the most important, what can we do? Is there anything that we can do to make less problematic earthquake occurrences? For a start, I would just like to say some basic information about me, but you have already heard them all, actually. I got PhD in geophysics in 2015. And why I started with this, my thesis was the spatial position of the East Vardar-Ophiolite geophysical geological model and implications on its geodynamic evolution. Actually, these Vardar-Ophiolites are remains of Tatian Ocean, and nowadays remains of the Tatian Ocean is Mediterranean Sea. So it's all connected. Now in the territory of Serbia, where I come from, there is not such a huge magnitude earthquakes, but the whole this region is pronounced to high seismicity. Now I work as associate professor of geophysics at the Faculty of Mining and Geology. I'm also a chief deputy of the geological section on the faculty, and I was the president of Serbian Society of Geomorphologists. You heard about my basic research interest, but what I most proud of is that I really work on motivation, encourage and support of young scientists, researchers and students, regardless of where they come from or their starting position. My origin is from Balkan. We are not economically high-ranked country or region, so the science here is in a problem. However, we still have big success in all fields of science. So let's start with some really basic things. But these basic things are important to understand several next slides. As we know, the tectonic plates are in constant motion. They collide, diverge, or pass each other, and the energy resulting from this movement accumulates the plate boundaries or along the surfaces that separate smaller blocks within the plates, which means faults. Each rock can accumulate only a certain amount of tectonic energy, and when it becomes stronger, a sudden movements occur and energy is released, which is enough to bring the plates back to the equilibrium state, that is the state of the least energy. An earthquake represents exactly this process of energy release by the movement of tectonic blocks along the faults. This energy released during the faulting continues to propagate through the rock mass in the form of deformation. That is the form of seismic waves. Most of the recent earthquakes occurred along this kind of plates. I have to ask you to turn off your microphone because I have noise in my sound system. So most of this recent earthquake occurs on this kind of fault system, whether they were expected on them or not. What's happened with the magnitude and occurrences? I suppose that you are familiar with this. In the first column, there is a magnitude of the earthquakes, and the second column is their annual occurrence. This is a statistical form from the last 120 years. So as we can see here, those small magnitude earthquakes occurring a lot more than maybe some people expect. More than 1,300,000 times per year. And if we go to the bigger magnitude, we can see that earthquakes with magnitude 8 or more occurred one per year. This doesn't mean that if we had one earthquake with the magnitude 8 and more, that we will not expect that is for this year. No, this is statistical. And only in that way we should take a look on that. If we took a look on a list of the 20 largest earthquakes in the world until 2019, we can see the distribution of this kind of the earthquakes. This is a really strong earthquakes, and those magnitude listed here are not expected in Europe and not expected especially in Eastern Mediterranean region. This kind of magnitude are connected to these specific areas on the planet. We are focusing on this region, and as you can see, in this region we didn't have any of these 20 largest earthquakes. However, regardless of that, a lot of devastating earthquake has hit this part of the Europe. Here we can see the list of 21st century earthquakes, and here is the recent earthquake in Turkey-Syria border. This one is the highest instrumentally recorded earthquake in this part of the world, and probably in the modern history the deadliest earthquake in this part. We will consider why is that, and the problem here, which I see as a scientist, as a researcher, is that this earthquake was expected in scientific way, of course. It's not a surprise. It's not something that is unnaturally phenomenon. But I believe that the problem of this number of fatalities is human nature and problem. Here we can see the relative motion between the major lithospheric plates, and the most important part is that we have African plates from one side, Arabian plate from the other side, and Eurasia plate on the north side. The contact of those three plates are totally responsible for all earthquake and all seismic activity of the whole Europe and this part of the Turkey. Sorry. Here we can see the earthquake hazard map that shows the expected level of ground shaking at specific location due to future potential earthquakes that might occur locally or at greater distance. Ground shaking is expressed as a peak ground acceleration. Normally it's given in the percentage of G. The values are displayed calculated based on 2020 European seismic hazard model. And as you can see here, the regions with the highest earthquake hazards are Turkey, Turkey, Greece, Albania, Italy, and Romania. Of course, those are followed by the other Balkan countries. However, the earthquake hazard is also considerable in some regions of Austria, Belgium, France, Germany, Ireland, Norway, Portugal, Slovenia, Spain, and Switzerland. The earthquake risk map, which you can see on the right, illustrates the relative distribution of expected risk across the Europe through the composite index, and this index is produced by combining the average annual economic loss and the average annual loss of life calculated from the 2020 European seismic risk model. It's normalized by the GDP per capita to account the varying levels of resilience across Europe. Countries with the highest earthquake risk in Europe are Turkey, Italy, Romania, Greece, Albania. And the highest risk and thus the most severe consequences of the earthquake are expected in urban areas. Of course, those urban areas located in comparably high seismic hazard. Let's say specific example of such places are Istanbul and Izmir in Turkey, Catania and Naples in Italy, Bucharest in Romania, Athens in Greece, but also Zagreb in Croatia, Tirana in Albania, Sofia in Bulgaria, Lisbon in Portugal, Bristol from Belgium, and Basel in Switzerland. They all have a higher risk comparing with the lower risk cities such as London or Paris or Berlin. Why do we need this kind of maps? Because earthquake risk assessments should help to efficiently tailor mitigation measures to minimize economic and human losses, and to make everything in Europe more resilient against some future earthquake. As I mentioned on the beginning, And most of the earthquakes that occur in Europe are not surprise. We cannot predict the earthquake. We don't know when they will occur. I mean, in the sense of the date and time, but we know what region is pronounced earthquake. We know exactly where are the highest seismic hazard and where is the highest seismic risk. Those are public maps and public data, and everybody can access them. If somebody is interested in this, I can send the brochure as well as the links and other things. Here we can see the tectonic map of the Aegean and Eastern Mediterranean region. Here is showing the main plate boundaries, major suture zone, and major fault systems. Those white arrows shows the direction and magnitude of the plate convergence. Those small gray arrows mark the direction of extension. This extension is from Miocene to recent time, and you can see here this orange color and this purple color that delineate Eurasian and African plates affinity. I show you this map to realize how complex these tectonic settings is in this region. However, the recent tectonic events in Turkey is along this fault, East Anatolian fault zone, and it's connected to Arabian plate, Anatolian microplate, of course, Eurasia plate. In Balkan Peninsula, the most responsible is Adriatic microplates and its contact with dinarides, and in Greece, southern Greece, we have Mediterranean ridge, Cyprus Trench, and Aegean microplates, and so on. So the most complex story is in southern Greece. The Mediterranean region is seismically active due to the northward convergence, which is up to 10 millimeters per year of the African plate with respect to Eurasia plate along the complex plate boundary, and this convergence became approximately 50 million years ago and was associated with the closure of Tethyan Ocean. The modern day remnant of the Tethyan Ocean is Mediterranean Sea. The highest rate of the seismicity in the Mediterranean regions are found along the Hellenic subduction zone, and this is Hellenic Arc here in the southern Greece, along the North Anatolian fault zone of the western Turkey, and Calabrian zone on the southern Italy. Crust and normal faulting through this region is manifestation of extensional tectonics associated with back arc spreading. The region of Marmara Sea is a transition zone between this extensional regime to the west and this strike slip regime of the North Anatolian fault zone to the east. This North Anatolian fault accommodates much of the right lateral horizontal motion between Anatolian microplates and Eurasia plate on the north, as the Anatolia microplates is being pushed westward further accommodate closure of the Mediterranean basin caused by the collision of African and Arabian plates in the southeastern Turkey. This is a geodynamic model of the Eastern Mediterranean area, and as you can see, again, there is a few major parts that you should take your attention. This is the collision of African plate and the whole Eurasia plate. Here we have Apulia plate and one small Adriatic microplates. Here we have dinarides. On the other side, we have here Anatolian plate, which is between Arabic plate, African plate, and Eurasia plate. In this region, in Mediterranean region, earthquakes have historically caused the widespread damage across the central and southern Greece, Cyprus, Sicily, Crete, but also in Nile Delta, northern Libya, the Atlas Mountain in North Africa, and the Iberian Peninsula. As a matter of fact, in the 93rd, I think, the earthquake of magnitude 8.2 it was occurred, also one in 1926, 7.8 in Rhodos was instrumentally recorded, and that earthquake actually was the largest instrumentally recorded Mediterranean earthquakes. Both of these earthquakes are associated with subduction zone tectonics. Some period, some in historical meaning, between 1939 and 1999, there was a series of devastating strike-slip earthquakes with magnitude 7 and more that propagated westward along the North Anatolian fault zone. So if we take a back for a minute, this is the North Anatolia fault zone. And in 1999, the Izmit earthquake with magnitude 7.6 was located on the westward end of the fault, struck one of the Turkey's most densely populated and industrialized urban areas, and a lot of people killed there, around 20,000. Although the seismicity rates are comparatively low along the northern margin of African continent, large destructive earthquakes have been recorded and reported from Morocco and in the Western Mediterranean to the Dead Sea in the Eastern Mediterranean. A large earthquake in Mediterranean region have also been known to produce significant and damaging tsunamis, and one of the more prominent historical earthquakes within this region is Lisbon earthquake in 1755. Those magnitude has been estimated from some non-instrumental data, but it's estimated to be about 8. So what's happened in Turkey? In Turkey, on February 6th, 2 earthquakes occurred. Both of them was along the East Anatolian fault. What happened here? It's happened that Arabian plate pushed the to the northwest, yes, and it's one left lateral transform fault system. Actually, it's not one fault; it's a system of faults. And this region is also been active in the history. As a matter of fact, in 1939 there was also one large earthquake, but in the recent history, 1970, also one of the huge earthquakes occurred within this area. Which I like to say to my students. The whole world heard for San Andreas fault. It's also transform fault, but on the other continent, but it's a famous fault thanks to Hollywood and blockbuster movies. However, in the scientific and research circles, those North Anatolian and East Anatolian fault are, let's say, famous as well as San Andreas fault. They are capable to collect a huge amount of energy and, of course, to release the same amount of energy. The earthquakes with magnitude more than 7.5 are expected in this area. And in that sense, it's not a surprise. Here we can see the epicenter of those earthquakes. The first one of 7.8 happened nearby Gaziantep town, and it was pretty shallow. The hypocenter was shallow, less than 20 kilometers. And the second one, this with magnitude 7.5, happened is in close to Kahramanmaraş village or town, and it was also very shallow. In the first few minutes or hours, maybe days, this second earthquake was considered as aftershock. But it wasn't an aftershock. Here you can see preliminary observation surface fault rupture of the Kahramanmaraş earthquake sequence. These background colors are ground movements estimated from radar, from INSAR. And this image shows, of course, the aerial view of the fault and surface displacement. You can see that here. These two strong earthquakes, both with magnitude 7.8 and 7.5, were doublets. They happened on the two conjugate faults. You can see that on those focal mechanisms. It's not unusual to have this kind of doublets in history, but it's completely understandable why this smaller one, conditionally smaller, was in the first considered as aftershock. However, to be an aftershock, we should have almost parallel fault system to consider that as aftershock. Also, I saw on the social media that there is a huge fault system activated in Turkey, but I'm not sure what's actually happened there, so I didn't want to present something that I'm not completely sure what is it. A lot of aftershocks happened in that part, and I think that in the next couple of months, maybe the years, a lot of aftershocks will continue to happen there. The problem in Turkey is totally the devastated towns. Buildings are collapsed. The whole cities are collapsed. And a huge number of people is killed, and a lot of people is injured, and I don't even know about the economical damage, but I believe it's huge. But what we discussed here, if you take a look of this upper picture, you can see that there are some buildings that are standing, and some of them are totally collapsed. And there is a discussion since the civil engineering in Turkey, their seismological institute, Their experts are really great. Seismological Institute from Turkey is recognized in the world. They have a great scientist. They have a great experts. And somehow, and what I heard from my colleagues from Turkey is they cannot speak enough. What that means? That means that they speak but nobody listens. In Turkey, there is also some law and, of course, some strategy and some regulation in civil engineering and in building, but also they had several times in the last couple of years when they put on the side those regulations. And here what I can see is that here they didn't have enough geological engineering investigation, geotechnical investigation, and of course there is a lack of geophysical investigation for any building, for any bridge or tunnel or whatever. You need to have exactly precise investigation for concrete location, for concrete micro-location. Beside this, the constructions of those buildings are poor. The concrete used in this building is below every minimum, and all of this resulted with total damage in this area. I'm referring to Turkey, but I believe that the same thing is in Syria, because that is a border area. I don't expect nothing different in Syria, maybe even worse than Turkey. Here you can see how devastated the city is. This is the image of the same region before and after this earthquake. So we had extremely strong earthquake for this part of the Europe. I realize that since you are from Colombia and you are having news from the earthquakes in the Central and South America, I talk about continents, that maybe this magnitude are not so high. But you have to understand that all regulations and seismic hazard and seismic risk are written, and they are for a specific location and according to seismic hazard in that location. So I would like to say that actually this kind of the earthquake is expected in Turkey, in this area. Also, this kind of the earthquake is expected along the North Anatolian Fault as well. This kind of the earthquake is expected in the southern Greece. However, if we go more on the north, we cannot expect this kind of earthquakes or neither this magnitude. What's happening in Balkan Peninsula after the earthquake in Turkey? The public was interested in all what's going on, and a few days after that, actually on the February 14, one earthquake occurred in Romania. And this earthquake of magnitude 5.7, I will just stop for a second just to see if everything is okay. Yes, I believe it is.
Yes, everything is okay. Yeah.
Okay. This earthquake of magnitude of 5.7 shook Romania, and it was really shallow. That was the strange thing about this earthquake. And another strange things about this earthquake is this regional stress tensor is strike-slip or compressional. But this earthquake occurred along the normal faulting, and we of course have explanation of this. Even if the regional stress tensor is rather strike-slip or compressional, it is probably possible that along particular related surface we have a sort of normal faulting accommodating the block adjustment in the area. I talk a lot with journalists and with TV stations and public and so on, and everybody asked me one question: is this Turkish earthquake related to Romania? The truth is that we actually don't know. What this means? This is seismically active area in Romania, and maybe there is a possibility, since the huge amount of energy was released from the Turkish event, those energy had to go somewhere. It's really possible that that amount of energy from Turkish event that come to this part of the Europe added to the maximum energy that that area could adopt. This means that if Turkish event is somehow responsible for this, means that only is this earthquake happened a little bit earlier than it's happened anyway. This quake would happen for sure, maybe in 6 months, maybe in 2 years. This just a little bit forced the event, if there is a connection between those two earthquakes. To be sure in such a things, we should we had to be to make possibility to instrumentally measure the energy in the subsurface masses. This is not possible, so we only can guess is there any relationship between those two. But as I said, it's not surprise also to have the earthquakes in this part of the here it is, in this part of the Romania. As you can see on this hazard map on Romania, the whole this area is seismically very active and with high seismic risk. Here we talk about southern Carpathian region. In southern Carpathian region, we have two specific areas in Romania. One is eastern part of South Carpathians, where this exactly Cherna geofault belong, and we have western South Carpathian region, where is the well-known Vrancea zone fault system. The main differences between those two zones is that this Vrancea zone is usually characterized by deeper earthquakes and with greater magnitudes, and this part of the eastern South Carpathian region are characterized by shallow earthquakes, but with some moderate magnitude. So it's actually it's not a surprise to have earthquakes here. We in that region there were several catastrophic events in the same region. In 1977, a great earthquake hits Bucharest, and this earthquake has magnitude of 7.2. It has the epicenter in Ranchea zone. More than 105,000 people died in the capital, and more than 50,000 buildings collapsed or were terribly damaged, especially in the city center. There was actually one town, Zimnica, that was completely destroyed. The main problem was that this earthquake lasted for a long time, and but the epicenter was on depth about 100 kilometers. One of the reasons that earthquake in Turkey was so devastating is because of the shallow depth. It was a really shallow earthquake for that magnitude. Here in Romania, it was at depth about 100 kilometers, but it was also really a devastating earthquake. Here in the same region, in 1940, it also was one earthquake, also around 7 magnitude, and more than 1,000 people died and more than 4,000 were injured. The exact number was never established due to the war. And here you can see some photos from that event. And here you can see the main epicenter and the main intensities of the earthquakes that occur in Romania. Now if we go a little bit to the between Turkey and Romania, here we can see tectonic map of the dinarites and surrounding areas with major tectonostratigraphic. The most important part in this region is this Apenninic Peninsula and the Apenninic Plate, Dinaric microplate, but also Adriatic microplate. And all tectonics and all seismicity and all seismic hazard is due to this constant contact between Adriatic microplate and Dinaric microplate. Here maybe it's better shown. The constant pushing of Adriatic microplate to dinarites, of course related to African plate and Eurasia plate, are causes of all earthquakes that occurs along the coast of the Adriatic Sea, as well as in Italy. A lot of historically huge earthquakes happened here. Maybe not huge by magnitude, but huge by intensity. In the town of Dubrovnik, which is located here, one earthquake, not, of course, this is not instrumentally measured magnitude, but it's calculated 7.4. There, in this occasion, 5,000 people died, but in that time, it was about 80% of the population in Dubrovnik. The next one, really with a big intensity, was the 6.6 magnitude earthquake, which destroyed the northwestern part of Albania and the southwestern part of Montenegro. It was located here, in this part. The exact number of victims is not known, but according to reports and writings of then media in Montenegro, the entire coast of Adriatic shook, and there was almost no town where at least one house did not collapse due to the earthquake. Skopje earthquake it's here in North Macedonia. There it's with the magnitude 6.1. More than 1,000 people died, and more than 200,000 people were become homeless. This catastrophic earthquake was felt across 50,000 square kilometers. And some between 75 and 80% of the city was destroyed in this earthquake. After this earthquake and after the Banja Luka earthquake, we will see the next one, new regulation for seismic construction were adopted. Now, of course, today we have in Balkan Peninsula and in Europe, we have more modern Eurocode 8 regulations which should be applied. Yes, as I said, between 75 and 80% of the city was destroyed in this earthquake. This is the Banja Luka earthquake. Banja Luka was hit by earthquake with magnitude of 6, but intensity of 8. It started with the preliminary strike or pre-shocks. The hypocenter was at about 20 kilometers below the city. And around 100,000 apartments were completely destroyed. And here we had a Montenegro between Bar and Ulcinj. Earthquake, officially this is the strongest earthquake on the territory of the Balkans in modern times. The consequences of which were repaired almost a decade later. The earthquake that occurred had magnitude 7, caused catastrophic destruction with an intensity of 9 on the Mercalli scale on the entire Montenegrin coast, over a length of more than 100 kilometers. The epicenter was in the Adriatic Sea, between Ulcinj and Bar, at the distance of about 50 kilometers from the coast, I think. And in this earthquake, about 100 people lost their lives. In Montenegro, about 30 in Albania, but more than 100,000 people left homeless. Here you can see what's happened, and this was really problematic because, as I said before, after the earthquakes in Banja Luka and Skopje, this area got a new regulation, and this hotel was built according to new regulation, but it's collapsed. Most recent earthquake in Albania, in Đurić, is here, was in 2019, had a magnitude of 6.4 or 6.4, I think, and it's officially considered as the biggest earthquake in the Balkans for the last 30 years. A huge number of the buildings were collapsed in this earthquake, and there were a lot of injured people here. And here you can see what's happened in this area. It's also well known fault system in this part of Balkan Peninsula as well, and this Skadar patch fault system, the same familiar is this one close to Tirana, the capital of Albania. The next one very strong event that happened was in Zagreb, in capital of Croatia, 2020, with a magnitude of 5.5. The first one, the second one was with magnitude of 5. It's happened about 10 kilometers north of Zagreb, and the hypocenter of the earthquake was at the depth of about 10 kilometers, also one shallow earthquake. And this quake occurred in the area of the tectonic border between Dinarides and Pannonian region. And this region is seismically active, and some of the biggest earthquakes are recorded in this region. Luckily, there was a damage, but not a huge damage in the city. Unfortunately, a little bit after the Zagreb earthquake, there was another one, earthquake in Petrinja. This earthquake occurred on the fault that roughly runs to the northwest-southeast direction, and this fault is a boundary between two very different tectonic blocks, the Dinarids and Pannonian Basin. Therefore, it can be said that various stresses and displacements in these blocks are compensated to this fault. The main cause of the earthquake is actually is not too far, but it's far from location. It's Adriatic Sea and Dinaric platform, and this is the main reason of all earthquakes along the Adriatic coast. If we take a closer look at the fault system on which earthquake occurred, it can be seen that the movement of the faults during this earthquake was lateral. It was shifted horizontal and occurred on the plane perpendicular to the surface. This earthquake mechanism is actually very unusual for the area of Croatia, where the most of the earthquakes since the pressure of Adriatic have a compression mode, and the first estimates indicate that the earthquake occurred on the fault that runs northwest-southeast, and the length of the rupture of the fault is about 25 kilometers. This suggests that the northern part of the fault was moved eastward. And this is the SAR image that shows those are actually fingerprints of in SAR images with the focal mechanism in this area. And what's happened here is that there is a lot of aftershocks, and they also contribute to this collapse of the buildings. I'm sorry for my talk, I'm a little bit cold, so I'm doing my best. What's in Serbia? Well, the Balkan Peninsula is an area where some of the strongest and most destructive earthquakes in Europe have occurred during the last century. These were, first of all, earthquakes that occur on the coast of the Adriatic Sea. However, strong earthquakes often occurred in the interior of the continents, where their effects were disproportionately greater than those predicted and expected for those areas. What that means? That means that earthquakes with magnitude 5 or 6 produce a huge intensity, or other words, they made a much more damage than should. The seismicity of the territory of Serbia is described as moderate but constant, and it's located in the area of Balkan Peninsula, which is bounded on the all sides by tectonically very active zones. And the main reasons of the occurrence of the earthquakes in this region is regionally significant tectonic process, collision of the Adriatic microplate and dinarids. At the border of these two large units, a large amount of stress is created, and this is also transmitted to interior of the continents. So the biggest earthquakes are in Croatia, Montenegro, Albania, and so on. But also we have a transfer of this energy in interior of the continent. And that is the story of this. One of the most important data for seismic hazard assessment can be obtained from a complete and uniform catalog. The acceleration values shown on this map refer to the soil surface type A, and according to some definitions, soil type A is a rock which includes a maximum of 5 meters of weaker material on the surface. Where the condition is met, that average shear rate waves in the first 30 meters of depth greater than 800 meters per second. Seismic hazard is shown on seismic hazard zoning maps on the bedrock. So what's important to understand that mostly all seismic hazard map show seismic hazard for the bedrock, not for exact location. And this is one of the main reasons why you cannot use only this map when you want to build something. You need to do a specific investigation, specific measurements for the specific location, because you will build on the local soil. On the local soil, you will not build on the bedrock. The second, this input parameter for seismic analysis are derived from a condition that the building with some average exploration life of 50 years does not collapse, which corresponds to seismic effects with a probability of exceeded 10% in the period of 50 years. And this earthquake has a return period of 475 years. The second condition is contained in the requirement that limited damage can occur only as a result of an earthquake that has probability of being exceeded by 10% in the period of 10 years. That is an earthquake that has average return period of 95 years. Hazard calculation of those maps is performed using probability methods, and seismic hazard is represented by the maximum horizontal acceleration and the seismic effect by the reference maximum horizontal acceleration for the bedrock. There are three main seismogenic areas in the central Serbia. It's Kopaonik, Kraljevo, Rudnik, Valjevo, Mionica, but outside this area, the area around Vršac stands out, where the strong earthquakes have also been recorded, and also stronger earthquakes were recorded in the area of Svilajnac. This is not in the recent time, but historically there were there were earthquakes. Statistically speaking, this entire area is characterized by an average occurrence of one earthquake with magnitude greater than 5 on every 10 to 15 years. And here are some, let's say, the most damaging earthquakes in Serbia. This one is from Mionica. This is from Kraljevo. It's from 2010 with not such a great magnitude. It was 5.7, but also liquefaction has happened, and a lot of buildings were collapsed here. And Mladenovas in 2022 with magnitude of 3.8, but with not huge damage. But geologically speaking, this entire area is located on the old tectonic border, which now represents the boundary between Dinarides and Carpato-Balkan origin. That area should be characterized by the existence of some fundamental faults, along which many smaller faults have been developed. And this can be activated with the suitable yield of tectonic energy. How much influence these old faults have, we actually don't know, but generally speaking, it is completely logical that movements will be done along the already existing ruptures, because you need a lot of more energy to create some new rupture. Okay, let's say a couple of words here. When assessing the seismic hazard and reading such a map, one must always take into account the seismotectonic characteristic of the area for which the seismic hazard is calculated. It is usual to calculate the seismic hazard based on previously defined seismotectonic zones, which is mainly the results of an insufficient amount of the data on the seismotectonic characteristics of that research area, where the biggest problem is the definition of active faults. What means definition of active faults? The completely definition of their position, geometry, and kinematics. If the seismotectonic zone is understood as an area of the same seismological and now tectonic characteristics, whose seismicity can be described by the unique relationship between magnitude and frequency of the earthquakes, this would mean that the probability of an earthquake of certain magnitude is equal at any point of the seismotectonic zone. This is, of course, not true, because earthquakes are totally related to fault activity. And where there are no faults that have been active in the recent time, there cannot be earthquakes. It's important to know the position of active faults in any area, and knowledge of the fault geometry and kinematics is necessary to calculate the maximum expected magnitude of the earthquake. Of course, a fault surface with a larger surface area and a greater amount of displacement along it will cause an earthquake of the greater magnitude, while the kinematic type of the fault will also affect the way of movement of seismic waves that occurring during the earthquake. All these data are very important in the calculation of seismic hazard, and only if all these facts are known and if a good catalog of earthquake is available, it is possible to correctly define the seismic hazard, which will also lead to correct calculation of the seismic risk, and of course in individual micro location. So, are they expected? Yes. What can we do? We can behave responsible. We should be aware that we cannot predict earthquakes or stop them or to do anything about occurrences of the earthquakes. We have to be aware where we live and to build and behave according to this. Thank you very much. I would like to say a special thanks to Professor Ritsa from Aristotle University, Greece, and to my colleague Ana Mladenovic from my university. If you have any questions, I'm here. If not, let me know how this seems to you.
Thank you very much. Just if there are some questions, I think that you can put in the chat, or if you want to hands up or something like that, you can be in the chat. I think that we don't have any question right now, but I have one question. Okay, there are one question.
Okay.
Alejandro, you can
Go ahead,
talk.
Juanma, and let me go next.
Okay, thank you. Well, I wanted to ask you something that I saw in the seismicity slides, I think.
Okay.
Um, the seismicity slide have, well, the seismicity associated with the boundary between Anatolian plates and African plates, um, and yes, and it's kind of delineated with seismicity in that zone. But inside, or kind of inside the the Greek islands, I don't know if it is
Yes. Okay.
the the yes, the formal yes, that's it. Like inside the part of the Greek island, they are like yes, like there are not a lot of earthquakes, and it's I find like interesting because it's kind of in circle, and there are other earthquakes there. I don't know if the lack of seismicity there are occasionated or have like as consequence um, the far of the plate tectonics, or they are like kind of seismic gap there, or maybe yes, like other hypotheses that have been done in kind of absence of seismicity in some zones.
Uh, well, if you take a look, the all Greek islands are highly pronounced to seismicity, and they generate a very big number of earthquakes. Some of them, as you can see here, only earthquakes with magnitude bigger than 4 from any period, but uh, and the all seismicity of this part is actually caused by Asian plate and African plate. Asian plate as a part of Eurasia plate, as you can see here, but it's so as Anatolian plate and Asia plate are different plates. But sometimes people show them together, but they are totally different plates, and they have a totally different movement. As you can see here, Anatolian plate goes to this direction, and Asia plate goes to this direction. Ionian Sea and Apulia plate goes on this direction. So I'm not sure did I have I understand well your question. So if you can ask again, but more concrete.
Okay, yes, I was referring in the next slide in the part of seismicity, yes, that there are like a kind of lack of seismicity in the central part of the Greek islands.
Aha.
Yes, they are like a
No,
lack.
it's just coincidence. Let's say that
Okay.
all this part is with high seismicity, and maybe there are smaller magnitude, or maybe not so. Maybe they don't happen all the time, but the whole this part is actually highly seismically active. It's the same here. You know, it doesn't mean that in this part or in this part we don't have earthquakes. It just means that they are not so present, so much present.
Okay, thank you very much.
You're welcome.
Yes, we have another question. I think that Alejandro, it's maybe
Yes.
going to ask something.
Yes, well, first of all, I would like to say thank you for your conference. I think that it presented a very well a very well like approach to the we as American students, we don't know about the European tectonics.
Yeah.
So yes, I learned a lot today. Well, one question that I have, well, actually I have two questions. The first of it is that well, when you presented the a map of seismic hazard in Romania,
Okay.
well, I watched like the that uh, well, I don't know if like in the middle of the map there is a point of blue color. What does it mean? Because it is surrounded by like a medium seismicity, well, a medium hazard region. So well, I don't understand very well that map.
Okay. This is actually they used two hazard assessments for this map. If we can, but I'm not sure, is it possible? You can see here that they used two different scale. So when we refer to this blue dot, in a sense of intensity, it's actually this 7. So it's nothing special. That was my point.
Okay, okay. Well, yes.
It's
Thought.
not my map. It's their public map. So
Oh yeah,
maybe
yeah.
I
Okay.
should
Well,
change it. But
I thought that it represents something different.
no.
Okay. Well, and the next one is related to the. Well, I recently read well some investigations about how devastating was the well both the Turkey earthquakes
Yeah.
from last month, and I also read that there were some parts of the surrounding areas of the earthquakes that experimented like an acceleration of gravity of well an acceleration twice as the gravity acceleration. So and this like added to well the the fact that the earthquakes were very shallow,
Yes.
that that originated that devastation that we saw in the pictures and in the news. So well, what can you tell me about that acceleration? How or why was it seen in the surface?
Well, there is a lot of open questions with the earthquake in Turkey. The problematic is local soil. Uh, it's uh, it's actually problem with in a lack of information of the local soil, of the local geology, but that shallow part geology. I don't talk about regional geology and regional geological settings. They are all well known. But regarding to these local settings in the cities or villages, are either not investigated well for this purpose for the buildings, uh, or maybe I don't have all of those information. However, I can make a correlation with this earthquake that occurred in Serbia, in Kraljevo. That I mentioned, it was not strong, too strong. It was 5.7 magnitude, but made a lot of damage. It was because a big part of the city lay on the alluvial, and that, as I suppose you know, that kind of material is very bad for any constructions. Very similar thing we have in some, not in all parts, but in some parts of the cities in Turkey. So the biggest acceleration should be connected with the local soil.
Well, thank you for your answer. It was very clear.
You're welcome. Maybe any more question?
I think that we don't have any more question. Well, I would like to ask another question, and it's about the part that you talk about, that that about doublet earthquakes.
Yes.
In the part of the Turkey and Syrian earthquakes. Yes, this
Yes.
part I didn't understand very well about, like the conclusion that they say about this. This was clear doublet earthquake.
Well, when we have big earthquakes, and after that we have aftershock of that earthquakes, it's not unusual. But in most of the cases, that main shock and aftershock should be along the same fault system. Otherwise, it's not an aftershock. If those two earthquakes occurred on the same fault system, we could consider it as main shock and aftershock. But if you take a look on the focal mechanism and on the fault itself, you will see that those are conjugate faults, that they are not in the same system of the fault, not of the same fault system that moved. So here, in the first case, this main shock, you had this kind of the movements, okay? And this one, let's say main 7.8 epicenter. It's occurred because of this kind of movement. The second one, this of 7.5, is this one, and it's standing something like here. So they don't belong to the same fault system that moves on the same direction, and it's not the same cause of the earthquakes. You need fault movements to release energy. If you have two close fault systems that can acquire a certain amount of the energy, they can release certain amount of the energy. It's not excluded that this earthquake of 7.8 added energy to this fault system and force it to realize the energy maybe earlier than it would be for sure in some time.
Okay, thank you very much.
You're welcome.
So, well, I think that we don't have any more question. If there are someone that have more questions, please type in the chat or maybe put the hands up in the
Okay,
side
I
box.
will leave my email. If anybody have any question, just send me an email, or if you want to talk more, just see. If you want to talk more about seismicity in this part of the world and in this part of the Europe, just let me know, and I will be more than happy to help you.
Thank you very much. Well, I think that we can conclude this talk. Thank you very much again, Dragana, for this talk. It was really interesting, and have a nice day.
You're welcome. Thank you all for participating.
Thank you.